Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting math question. We have 2 to the power a plus 2 to the power minus a equal to 4. If you have your answer, your approach, you can write your approach down into the comment section and then we will check our answer. So right now let's start. First of all, let's multiply both sides by 2 to the power a. Okay, so let's do this right now. We're gonna multiply our left side by 2 to the power a. So we have 2 to the power a on the left side. We're gonna have this expression 2 to the power a plus 2 to the power minus a, and we're gonna multiply our right side by 2 to the power a. So we have 4 times 2 to the power a. So it changed nothing. We just multiplied both sides by 2 to the power a, by this 2 to the power a, and by this 2 to the power a. What we're gonna do next? Let's multiply this 2 to the power a by these parentheses. As a result, what do we have? We have 2 to the power a times 2 to the power a. Yeah, we're gonna multiply these both, and right here 2 to the power a times 2 to the power minus a. So plus 2 to the power a and times 2 to the power minus a equal to 4 times 2 to the power a. Right now, let's look closely. What do we have? We need to know a really important math property, a really important math rule. So whenever we have the same base but different powers, so whenever we have a to the power m times a to the power n, we can write it as a to the power m plus n. So as a result, let's write right here as 2 to the power a plus a. Yeah, let's do this. So we have 2 to the power a plus a. And right here we have plus 2 to the power a minus a equal to 4 times 2 to the power a. Right now, let's look closely. What do we have? 2 to the power a plus a equal to 2 to the power 2a. Okay, 2 to the power 2a. And we have plus 2 to the power a minus a equal to 2 to the power 0. So plus 2 to the power 0 equal to 4 times 2 to the power a. Okay, 2 to the power 0, 2 to the power 0 equal to 1. So as a result, I just want to change in order a little bit. So first of all, on the second position, let's write this expression with the negative sign. So 2 to the power 2a minus this expression from the left side. So 4 times 2 to the power a. And we have right here plus 1 equal to 0. Right now, let's look closely from the different angle, because we have 2 to the power 2a, 2 to the power a. So it looks like this is a quadratic equation. But first of all, we can easily write this 2 to the power a. We can write it as 2 to the power a. We can write as 2 to the power a raised to the second power. Yeah, we can write 2 to the power a raised to the second power minus 4 to the power 4 times 2 to the power a and plus 1. And right now, from this angle, we can easily see that this is a quadratic equation, okay? Because this is the same thing as 2 to the power 2a, and when we write a substitution, so real quick substitution, so let 2 to the power a is equal to, for example, let's go with x. We don't have x at all, so 2 to the power a equal to x. So as a result, we have x squared. Okay, so as a result, we have x square minus 4 times 2 to the power a equal to x minus 4x and plus 1 equal to 0. So as you can see, this is a quadratic equation. So right now, let's solve it with all known methods. So I can easily solve it with the method of coefficient. So this is up to you. I'm going to solve it step by step. So maybe a lot of students watch my videos. So this is a step-by-step explanation. So a equal to 1, b equal to minus 4, and c equal to 1. This is all known method of coefficients. How can we solve it? So discriminant real quick equal to b squared minus 4ac equal to b squared, so minus 4 square minus 4 times a times 1 and times c times 1. As a result of a discriminant is equal to 16 minus 4 equal to 12. So our discriminant is equal to 12. So right now, let's plug in the discriminant in all known formula. So we have x first and second equal to minus b plus minus square root of discriminant and all over to a. So let's plug in it. So minus b, so we have minus 4 plus minus square root of discriminant equal to square root of 12 and all over to a, 2 times 1. As a result, minus minus, when we multiply it, equal to plus. So we have 4 plus minus square root of 12. How can we rewrite it? We can write it as square root of 4 times 3, okay? And in our denominator, 2 times 1 equal to 2. So right now, let's split this square root, this multiplication inside this square root sign. We can easily do this according to a square root property. We can write it as a square root of 4 times square root of 3, and we divide it by 2. Right now, square root of 4 equal to 2, so we have 4 plus minus 2 square root of 3 over 2. And the final tricky move, a lot of students forget about it, we can divide our numerator by 2. Okay, we can write it as 4 over 2 plus minus 2 square root of 3 over 2. And as a result, 4 over 2 equal to 2. And we have 2 plus minus, right here we're going to cancel these 2, so 2 plus minus square root of 3. So we have two roots. So x first equal to 2 plus square root of 3, and x second equal to 2 minus square root of 3. But don't forget about our substitution, because right here we have it, 2 to the power a equal to x. And don't forget about our equation, because we need to find it, we need to solve it in terms of a, and we have our substitution, 2 to the power a equal to x. So let's write, but 2 to the power a equal to x. So as a result, we have two equations, two pairs of solution, two branches. So 2 to the power a equal to x. So right now, let's solve, for example, our first part, when 2 to the power a equal to x first. So 2 to the power a equal to x first, and let's do this. So x first equal to 2 plus square root of 3. So we have 2 to the power a equal to 2 plus square root of 3. So how can we find right here our a? So let's write log on both sides. So it changes nothing for us, but in the same way it helps us a lot. So log, doesn't matter what log you choose. So we have log 2 to the power a equal to log 2 plus square root of 3. Right now, in terms of log property, this a will come down right here. So this is our property. So whenever you have log log a to the power b, we can write it as right here. We can write it as b times log a. Okay, so we can easily write it like that. So right now, let's solve it. As a result, what do we have right here? We have a log. We have a log 2 equal to log 2 plus square root of 3. Okay, and right now let's find real quick our a, because we need to divide both sides by log 2. So dividing both sides by log 2. As a result, we have right here our a first equal to log 2 plus square root of 3 over log 2. So this is our a first. But according to a log property, so I'm going to write this property right here real quick. So let's write this property right here. So this property looks like that. So whenever we have log a over log b, you can write it as log a base of b. So we can write it like that. So as a result, we can write this our a first as log of 2 plus square root of 3 base of 2. Okay, this is our a. This is our a first. Really great. This is our a first. Right now, let's find real quick our a second. Don't forget about it. We have it right here. So this is our x first. We plug in x first to this equation. Right now, let's plug in x second to this equation. So as a result, we have 2 to the power a equal to x second. Okay, so our second part of solution. So our 2 to the power a equal to x second, but x second equal to 2 minus square root of 3. Okay, so as a result, what do we get from here? We have 2 to the power a equal to 2 minus square root of 3. According to a same principle, we can have right here, we can have a log of 2 to the power a on the left side equal to log 2 minus square root of 3. Okay, right now this a will come down right here. So as a result, we have a log 2 equal to log 2 minus square root of 3. According to a same principle, we're going to divide both sides by log 2. So we have a second equal to log 2 minus square root of 3 over log 2. And the final tricky move, we can easily write it as log 2 minus square root of 3 with the base of 2. So we have our a first right here and our a second. Let's write our final answer, and then we can easily check real quick our roots. So our answer, our a first equal to log base of 2. Right here we have 2 plus square root of 3, and we have the second root, so a second equal to log base of 2 of 2 minus square root of 3. So we have two roots, and right now let's check this root real quick. Let's do this right now. So we have a first and a second. For example, let's check a first. Let's do this. Let's split it. Okay, let's do this right now like that. Let's separate this part. So right now let's check it real quick. So our check of a first. So first of all, let's write our equation from the beginning. So in the beginning we have 2 to the power a plus 2 to the power minus a equal to 4. Let's check real quick our a first. Let's do this right now. So a first we're gonna plug in right here. So as a result, what do we have? 2 to the power a equal to this one. So we have 2 to the power log 2 base of 2 of 2 plus square root of 3 plus this 2 to the power minus a, we can write it as 1 over with the positive, so with the same thing, so we can write it in our denominator, not with the negative sign, but with the positive sign. So 2 to the power log 2, so absolutely the same thing, 2 plus square root of 3, and equal to 4. Right now, if you look closely, if you know a little bit about log, so b to the power log base of b of a equal to only our a. So this is our property that we really need right now, because we can easily cancel b and log b. In our case, we can easily cancel 2 and log 2. So as a result, we can consider this expression as 2 plus square root of 3, 2 plus square root of 3. So we're going to cancel these 2 and this log 2. We're going to have 2 plus square root of 3 only, plus the same thing on the right side, or right here. So 1 over the same thing. We're going to cancel 2 and log 2. As a result, we have 2 plus square root of 3, 2 plus square root of 3 equal to 4. So as you can see, we don't have anymore, we don't have a log. So right now, let's simplify this expression. How can we do this? Of course, let's find our common denominator. So let's do this right now. Our common denominator is equal to 2 plus square root of 3. 2 plus square root of 3. Right here we have 2 plus square root of 3 plus square root of 3 times 2 plus square root of 3, 2 plus square root of 3 and plus 1 equal to 4. So this is our 1, yeah, this is our 1, yeah. Right now let's multiply our parentheses, but in the same way we can write it as 2 plus square root of 3 to the second power. We can write it as 2 plus square root of 3 to the second power plus 1 over 2 plus square root of 3, 2 plus square root of 3 equal to 4. Right now let's raise this to the second power. Let's do this right now. So as a result, what do we have? We have 4 plus 2 times square root of 3 plus square root of 3 square and plus 1 over 2 plus square root of 3, 2 plus square root of 3 equal to 4, so the same denominator. Right now let's simplify a little bit our expression. So I just wanted to continue right here because I don't have enough space. Yeah, so as a result we have 4 plus 2 times 2, we have 4 square root of 3 plus 4 square root of 3 plus square root of 3 to the second power equal to 3. So 3 plus 1 equal to 4. Yeah, so plus 4 all over 2 plus square root of 3. 2 plus square root of 3 and equal to 4. Right now 4 plus 4 equal to 8. So we have 8 plus 4 square root of 3 over 2 plus square root of 3 equal to 4. In our numerator, we can easily factor our 4. So we have 4 in a parenthesis. We have 2 plus square root of 3. 2 plus square root of 3 over 2 plus square root of 3 equal to 4. And right now, the final moment, we're going to cancel 2 plus square root of 3. And we have 4 equal to 4. So our left-hand side is equal to right-hand side. So our root is correct. This is like your quick homework. You can easily check. A second, but I think everything's gonna be great there because you're gonna have the same algorithm and the same principle. How can we check it? So our root is a first is great, and with the and a second is also great. You can easily you can easily check it. So a great question. I really hope you enjoy it. I really hope you understand it. So it's not that easy. A lot of students might be thinking this is an easy question because we have 2 to the power a plus 2 to the power minus a. So it's not like a huge coefficients. It's not like a huge powers. But in the same way, this is not that easy question, to be honest. With a lot of really interesting things, a lot of really interesting steps right here. So you can easily see this solution once more. You can easily pause the video. You can easily see how can we solve this question correctly and step by step. Okay, this is my solution. So I really hope you enjoyed. I really hope you understand my explanation, and thank you for watching. Wish you all the best in your life. Take care of yourself. Also write your response, write your answer, write your thought about this question down into the comment section. It's also really great to discuss this question in the comments below. And thank you for your time. Have a great day and see you in the next videos. Take care of yourself and wish you all the best.